All right, guys. So this is our earnest project presentation for the human brain interface. The vibe of this project is to enable telepathy through digitization, which sounds a little esoteric, but the idea is that we can have a linkage between brains. And there are a lot of considerations of this idea. While this idea seems quite innovative in its own right, there are ethical privacy issues, and the subject touches many different fields: anthropology, psychology, law, ethics, social sciences in many different ways, and of course, not to mention the technical bit. So we've got three high schoolers here: Parwan, who's a senior, Ikjot, a sophomore, and Simmer, a junior. These three folks know what major they want to pursue. And in their intros, I think I'll request them to unravel that. But we have a mix of law, computer science, and medicine. So these three folks learned research skills to produce the final outcome that we are going to see here today after 8 weeks of work that led to a white paper. And so I'll let you guys take it from here. And I look forward to your presentation.
Thank you. So this is our research paper, The Human Brain, Unlocking Its True Potential. So my name is Parwan Virk. I hope to pursue a major in computer science and become an entrepreneur.
My name is Ikjot Bali. I hope to pursue a career in medicine or biomed.
My name is Simar Gandhi, and I would like to pursue a career in law, have a major of paralegal studies. And let's continue.
So here is our introduction. So companies like NVIDIA, ChatGPT, IBM, Adobe, and Anthropic have significantly shaped our understanding of the future of artificial intelligence, focusing on AI hardware, algorithms, and the interplay between artificial and human intelligence. These innovations form the foundation of a human network infrastructure that aims to surpass current technologies, creating a human-centric system of efficiency and effectiveness. These tools or concepts are what build the infrastructure of the human network, eventually surpassing the technology we have and building a human-centric system of efficiency and effectivity. To grasp the connections between AI and the human network, we must explore the tools that have inspired this research. Today, we will be focusing on understanding AI and human intelligence, the AI and development and backbone, and the future of this new human network.
As Parwan has discussed, we are going to be talking about the tools that have inspired this research, including AI hardware and machine learning algorithms. What's unique about AI hardware is that it is made up of GPUs as opposed to CPUs. GPUs being graphic processing units and CPUs being central processing units, one being more effective and quite fast than the other, being GPUs. Companies such as NVIDIA make powerful GPUs that are now being sold to large companies such as Google, Amazon, Apple, Oracle, and etc. for their own AI needs. Moving on to some other tools. Machine learning has come to use with the training of artificial intelligence, combined with computer science, using data and algorithms as a base for predictions and decision-making, filtering out data for the best possible outcome. Overall, there are 3 different algorithms used by AI companies. The first being supervised learning, including labeled data sets, which include inputs and the corresponding outputs, allowing the model to grow over time, such as image and object recognition, predictive analysis, and etc. The second being unsupervised learning, with unlabeled data and discovering patterns that help solve clustering or association problems, like anomaly detection. The third being reinforcement learning. Artificial intelligence learns to make decisions by interacting with an environment, For example, Netflix or YouTube, using things with user recommendations based on history. These algorithms open a new avenue for artificial intelligence, but also the possibilities for enhancing the human network via different types of learning. However, we first need to understand the correlation between the AI of today and HI. Next slide. So in discussing the potential of artificial intelligence, we often leave human intelligence unacknowledged. Both forms of intelligence work similarly in some ways, and with further research, we can apply what we know about HI to AI, reaching our full potential. Some of these similarities include learning and adaptation. So humans gain their learning from experience, and AI can use machine learning where it's processing data and making decisions based on that. Pattern recognition is embedded into our cognitive process, and AI can recognize that, seeing data like anomalies in data using unsupervised learning, for example. Problem solving, humans can do both moral and logical problems, and AI often deals with logical problems regarding computing and more of the coding aspects. Decision making, both can make decisions based on certain rules, while humans have a more emotional aspect. AI strictly goes off of the rules that was inputted. Error and adaptation, similar to learning and adaptation, both can correct themselves after receiving feedback, either from a person or from another computer. And also communication, as we see with ChatGPT and even between other computers. However, there are some key differences, including consciousness, emotions, and processing feelings or creativity. Our goal as a whole is to take the advantage of the resources and knowledges we have with artificial intelligence, applying it to human intelligence, while we're seeking the analytics of AI, but having the emotional intelligence of our species. Next slide.
Okay, so before we're able to conclude about any new findings about the human network, we first need to take a step back and demystify the human mind. Even today, the human mind is a topic that's surrounded with great mystery. But by understanding the human mind as much as we can and pushing for the limits of what we already know, we will continue to build a strong foundation to our goal, which is engaging and improving the effectiveness of the human network as we know it. So the human brain works as a control center for the body. There are three main components to the human brain. It's the cerebrum, cerebellum, and the brainstem. The cerebrum controls the thought, memory, and action functions of the brain. The cerebellum controls balance, movement, and coordination. And the brainstem, which attaches the brain to the spine, also controls vital functions such as breathing and heart rate. Inside all of these different regions are billions of neurons that interact and communicate through electric signals. The neurons are made of the cell body, dendrites, which receive signals from other neurons, axons, which transmit signals to other neurons and muscles, or the synapses, which are the junctions between the neurons and the neurotransmitters that are released. The brain basically works by processing this information and making a decision based off of it. And by information, I mean the information that the neurons collect and find. Though we may not realize it, the crosstalk between our senses and our brain are one of the most important ways our brains receive any kind of information. This process is called sensory integration. The processing of the sensory output begins in the different regions of the brain, but then it becomes integrated, which allows the information to be interpreted as a motor response. Most of the time, we're not even halfway aware of all the sights, sounds, and smells that our brain interprets in our environment. But our brain is constantly processing these signals through our senses and other sensations too, such as pain, pressure, temperature, or joint position, and more. When these neurons communicate, the brain waves are produced. Next slide. So now that we've discussed the brain, we need to go back and talk about now that we've discussed the brain, there's a common question that's often asked about genius being a learned behavior or not. So a genius is often defined as someone with an exceptional nature, ability, or talent. And there's a common question that stands, whether a genius is a learned behavior or something that has more genetic characteristics. A study conducted by the Washington University School of Medicine says that genetics can drive anywhere between 30 to 75% of the variations in a person's IQ levels depending on the individual. But on the same idea, an article written by Times explains how most geniuses gain their intelligence from their environmental conditions, explaining how environment is crucial for activating genetic traits, such as good parenting relationships, encouraging comments, constructive criticisms, and regular feedback that could all help foster a child's genius potential. So now that we know that there's no clear answer to a genius being a learned behavior or not, and it's still a question surrounded in a great mystery, how can we as people become geniuses of our own? With every repetition of thought and emotion, we create and enforce a neural pathway in our brain. And with every new thought, we basically create a new being. And with these small changes, we can change how our brain works. Next slide.
Okay, so now we're going to be building the bridge. So brain-computer interfaces, or commonly referred to as BCIs, are technologies that establish a direct communication pathway between the human brain and an external device, typically a computer. These systems allow for bidirectional information flow by either recording brain activity to control external devices or by stimulating the brain to provide sensory feedback or alter brain function. So these advancements in today's society have led to BCIs being compared with telepathy. So telepathy, although it may sound like a fantasy, actually has a significant breakthrough today. So the ability to communicate with others throughout thought transference has long captured the imagination. However, recent breakthroughs today have proved for certain telepathic traits to exist. Recent research on mirror neurons suggests that we can unconsciously pick up on the emotions and intentions of others based on their subtle cues. The human sensory network and computer AI networks share parallels that highlight the remarkable similarities between biological and artificial intelligence systems. Both rely on the processing and interpretation of information through different mediums and mechanisms. So, in conclusion, BCIs can be applied in many scenarios. For example, providing assistive technologies for individuals with disabilities, providing rehabilitation for strokes or spinal cord injury patients, creating an enhanced human-computer interaction, producing cognitive augmentation, and giving better gaming and virtual reality control. In this case, we will use it to improve efficiency and collaboration. There have been recent advancements in BCIs. Companies like Neuralink and Synchron are working on advanced invasive BCIs, while others are focusing on non-invasive technologies. Research is ongoing to improve signal processing, developing more biocompatible materials, and expanding applications. In summary, let's go over to what we reviewed today. Simmer, can you please cover AI hardware and the artificial intelligence and human intelligence?
Absolutely. Regarding AI hardware, we have discussed GPUs as compared to CPUs, GPUs being more efficient, having better image rendering, overall efficiency compared to CPUs, and companies like NVIDIA using them and spreading that to Google, Amazon, Oracle, and etc. for faster AI and more efficient AI. And machine learning, we've also discussed, it comes into use to filter out the data for the best possible outcome with 3 different algorithms: supervised learning, unsupervised learning, and reinforcement learning, all trying to work with the user to make the experience a bit more easier. And all these algorithms open up a new avenue for artificial intelligence. Regarding AI versus HI, we know that both of them share the similarities of learning and adaptation, pattern recognition, problem solving, decision making, error and adaptation, and communication, with differences in the more creative and emotional aspects such as consciousness, emotions, processing feelings, and creativity. And our goal is to take advantage of all of these resources. Moving on to Joel.
So today we sort of demystified the human mind and discussed the many components that are in play when we're thinking or even just existing around. And we also discussed the long-lasting question of genius being a learned behavior or having more genetic characteristics. Moving
Thank
on
you.
to Parvan.
Thank you, Ikjot. So by building the bridge, let's recap. So brain-computer interfaces, or commonly referred to as BCIs, are technologies that establish a link between a brain and a computer. It allows for bidirectional information flow. And as for telepathy, BCIs have been likened to it, enabling communication through thought. Research on mirror neurons suggests that we can pick up on others' emotions and intentions unconsciously. So, as we continue to advance technologically in today's society, we may uncover a deeper understanding of the universal languages that bridge the gap between biological and artificial intelligence, paving the way for more synergistic interactions between humans and machines, and for the possible outcome of the human system mimicking the AI system. We hope that this research can put a spotlight on an exciting future opportunity. Thank you everyone for listening to our research project today. Does anybody have any questions? We will be opening the Q&A panel now.
Participants, mom and dad, parents of the three presenters, any thoughts, comments, questions?
Yes, I do have a question. Any of the presenters could answer that. What were your takeaways from this particular research, and where do you think this research is going to go next?
I think everyone can take a chance to answer their own responses. So who wants to start?
I don't
I
mind
can-
starting. Oh, sorry.
Sorry, you can go ahead. Sorry.
Thank you. Before I had a very strong opinion of artificial intelligence, the one I had created in my mind, that artificial intelligence was simply simply a new technology that was supposed to kind of replace human intelligence. But now that I see a lot of the potential with both working together, I think I've taken away that there's a lot of undiscovered potential in both human intelligence and artificial intelligence. And we could really, we could really advance human intelligence via really non-invasive ways. And we can use AI to supplement that. And not only from the research alone, but just from this whole process, these full 8 weeks, I think I've gathered a lot about collaboration and how much that working together, we can discover so much more. And I think with more of that collaboration, we can unearth more about both of these topics and how to merge them together.
Thanks, Simar. I'd just like to, before the others join in, I'd like to get a little bit more detail from you, Simar, since you focused more on the legal. That's your legal is your side of what you want to pursue with your career. I'd like to understand if you want to build a little bit upon the ethical issues of this whole research. Did you have any thoughts around the legal implications?
Absolutely. Around the legal implications, there are a lot of ethical and both societal concerns, like privacy concerns regarding brain data collection with things such as when you're trying to sync brains together. There's a lot of questions regarding both data privacy and a lot of things regarding neuroscience data. A lot of laws have been set to limit this, which is partially why we don't have too much information on this. Any non-invasive tech is what we are trying to encourage here. And I also believe in encouraging the non-invasive technology because nowadays it feels like a lot of things are becoming more tech oriented and we are possibly intruding on some privacies, but I have very strong opinions that some of those privacies should not be messed around with. But sometimes these laws kind of create boundaries for more research, which I understand. And I think that we are going to continue to work around it in the future. And I would love to pursue any future opportunities to work with actual people and AI companies to be like a sort of tunnel for both of the ideas and reaching a common point.
Thank you.
Thank you, Simmer. I guess I'll go next. So I think this project has really opened my eyes for these future opportunities. So before I took on this research project, I had some different opinions as well regarding AI and whether it would affect any future career that I would be pursuing. But now that I've taken on this project, I realize that human intelligence and AI intelligence can both live together harmoniously. And I think AI is here more to help us than to harm us. And I think that um, if we really, if we really focus more on uh, AI, if we really make it better, I think that it will be better for all of us. So actually, a few years ago, the market valuation for the AI industry had a market value of around $47 billion. And a few years later, I'm sure that market valuation has increased by a lot. So there's more opportunities. Any rumors regarding that opportunities will be lost with AI, I do not think that that will be really significant in the next few years, as that human intelligence and AI intelligence will benefit us more than harm us. So regarding this project, I think one challenge that that we really faced was the challenge of ambiguity, because this is a new emerging field. We did go in without a lot of support, but through the help of our advisor and through the help of our fellow teammates, we really pushed together this research proposal that that we think that this project is worth pursuing, and for more it should be considered as something that should be focused on in the future.
Okay, thank you, Parvan. One follow-up question on that one. Since your interest is more on CS and entrepreneurship, where do you think some practical use cases for opportunities around entrepreneurship would lie in this field?
Sure. So one of the biggest topics that we focused on was this project focuses mainly more on human collaboration using AI. So regarding the business side of things, I think that AI can really help a business, providing new ideas, providing helping it with organization, um, providing summaries, providing it is basically a virtual assistant, which, if used correctly, can really improve the efficiency of a business, which will help them grow. Regarding the economy aspect of AI, I think that again, with the $47 billion valuation a few years ago, I think that if people really focus it more on it, I really think that people can create more entrepreneurial opportunities. This is a whole new field that has been opened up. And so if more entrepreneurs focus more on AI and machine learning and create their business ventures starting from there, I really think that this is just a new opportunity waiting to be tapped into.
Understood. So it's going to be quite a focus on micro level computing in terms of hardware, and a lot of software related opportunities between the human and the computer, spoken languages, as we call. Thank you.
Well, Simmer and Parvan both said basically everything that I was going to say. But when I walked into this project, I only had a one set kind of mind about AI, and I only understood it as like a virtual assistant that would help me figure out what to write on this paper. Um, and I just saw it for ChatGPT. But during this project, I did understand and did learn a lot, and basically dived into a field I never thought I would ever, pursuing like keeping a one-track mind about medical. But through this project, I've understood like there's many implications for AI, and AI is our future. So it's really, really important to keep myself updated on it. And there are many implications to AI, such as Neuralink, which I now find very fascinating and want to maybe see more about in the future.
Can I ask you a follow-up question on that? Look yourself as a doctor, maybe you're a surgeon sometime in the near future. If you are presented this opportunity to implant some microchip in the brain of a human brain, would you think you would be open to doing that? Or what kind of training or ethical issues or anything else that you would think go through before you would agree to do such as invasive surgery?
So if I was a surgeon and the tech had advanced to the point where the microchip was beneficial for my patient, I would have no issue with putting a chip in my patient's brain. Again, there's some moral and ethical considerations that should have been brought up before, but looking at the future, I think AI can very much help medicine and um, help medicine and that field and like basically medicine in a way that humans can almost maybe never do. So I say yes because I think it's important to keep the future as open as we can. And yeah, that's all I got.
Okay,
I
thank
hope
you.
that answers your question.
Thank you. You did, yes.
Any other questions from or comments from other folks in the room?
First of all, great job, kids. When all three, Pravan, Simar, Igjot, you have done a phenomenal job in last 8 weeks. A topic that was very new to three of you. You have done good research work and have put together good stuff. So well done. The question that I have is what rather it's a question for questions. So what questions do you have in your mind that you want to get an answer for in the next phase? And what this is first thing, you three can give ideas about what next, or what are the questions that you have in your minds that you want to get an answer for, learning a lot. And what would be the next thing that you would like to learn or research about?
I'd be happy to answer this question. So basically, this research, I think it's not done yet. I think that since we are focusing mainly on improving efficiency with human collaboration with one another, I'd be happy to research next on actually building this process of efficient human collaboration. I think that would be my next project. Regarding questions, again, it's focusing more on the main idea of our topic, which is mainly questions regarding how we are going to approach this process. How are we going to approach creating this system of efficient human collaboration? And I think that this research that we have done will help answer our questions. So now we've collected the data, we've made all of the proposals. Now it's time to put this in action.
Thank you. Simar or Igjot, do you want to add?
Simar, you can go first.
Okay. So as far as I understood, you wanted us to answer the question of what questions do you have and where do you think this will go, correct?
Yes. Sorry, my dad just went away, but yes.
Okay. So regarding where I think this will go, I would, much like Marwan, I would like to see this in action because I firmly believe that while research and development is very important, actually enacting upon the research is equally important because there's a lot of research on AI and HI. There's a lot of independent research. Now that we are combining this together, I believe we can try to create some non-invasive way to connect both AI and HI. And my question regards to being able to do that, being able to, how do we combine both AI and HI without being invasive, or how do we do this in a way that is legal, safe, and approachable for other people? Thank you.
Thank you. Good. Ajot, what are your
So
thoughts?
if we're talking about, wait, what was the question again?
What are the questions that you have in mind after working on this project?
So in my mind, I think that my question is what's gonna happen next. So now that we've kind of, in my opinion, now that we've kind of got an understanding on the background of this and seen where it can lead, I'm interested to see in what fate has to show us next, or to show us like what next big thing will pop up through this research. And I'm interested in the future implications basically of where this is going to lead us, and see how different emerging fields that were once left as like too hard to figure out can change through this, like dreams, for example, in psychology, using basically Neuralink tech, or using more tech that's invasive in the brain. We're going to have a better understanding of those fields than we had before. So does that answer your question?
Kind of, okay. And what are the next things that you have in mind? What are the questions like that are not answered yet?
Guys, what do we think? We can start.
So part of that has been addressed before when Jayant was asking questions about their next steps. And I think in the realm of their domain, law,
Mhm.
medicine, and computer science, computer science/business, those three lenses are very nicely answered. But if there are additional thoughts, yes, please, let's add those. Ajot, Simar, Pravan.
Jyot, you can go.
Okay. So some questions for the future that I would have in any realm or domain would be how is AI and this kind of tech going to change how we see normal, like, educational standpoint in learnings, and how our everyday lives are sort of going to change through this tech.
Mhm.
Another future implication would be, again, how are some of the fields such as dream research, or other sort of not forgotten fields but hard to research fields change through this tech and through this research, and understand and connecting of brains, and how can we learn more about behavioral sciences as well through this tech as well.
Like, how can we make dreams come true?
Yeah.
Yeah.
Mhm.
Oh, this
Okay.
is a great dream.
Simar or Pravan?
I can go. I think my questions again regard more to like the legal aspect of these things. With 2022, but the Biden administration passed the CHIPS Act, which authorizes more GPUs being produced in America, more of these AI technologies not coming from other sources, but in fact being built and made in America. So I think there's going to be a lot more AI coming up here, especially in this country. And what I wonder is regarding all the laws and concern for potential misuse and surveillance or manipulation or gathering of sensitive information, how are we going to deal with the limits that are legally put, and how far can we push these limits, and will they change in the next 2 years? That's all.
My questions are similar towards Simmer's, focusing more on regulations. My questions were, how can we put regulations on AI, so loose regulations, so that it's flexible enough that we have control over expanding businesses and the economy, but tight enough so that there is no misuse of it, such as in recent news and recent events we've seen AI impersonating, creating false images of other people. So those are ethical considerations that we need to look at, but it is important that we have tight enough regulations that we do not have malpractice such as that, but we do have loose enough regulations that we still have freedom to use AI for different things economically related, such as predicting the market. And I really think that I just really think that if we take care of this right now, none of us will, the damages, there will not be many damages. Instead, it will, again, like I said, benefit us more than harm us. So these regulations, such as in recent events, there's been talks about having a watermark on images to say that this is AI. I think that that is good enough because it is not strict enough to limit the use, to limit creating AI images altogether, but it is strict enough so that people know that it is AI who is creating these artificially generated images. So that was just my question. How are regulations going to look like within the future for regarding AI and what we can do, how we can use it, and how well we can use it, how much we can use it? So that was just my question that I had.
Awesome.
Thank you.
So I guess, guys, for sake of time, are there any closing comments from anyone? And then we'll wrap up.
My only closing comment is that this research paper that we have made, we hope that it can be used for furthering on future research, such as pursuing the topic of increased human collaboration. I definitely will be looking more into it as well, but this research is helpful for anyone who is going into the AI and neuroscience department.
I would also like to just say like a thank you to Bob Uncle and the team for a really nice research project and a good way to spend my summer. I did actually really learn a lot. So
yes, this project couldn't have been possible without our advisor. So thank you very much for making this happen.
Same final conclusion, I guess. Thank you to both Bungle and principal and our principal, Mr. Rick. Thank you so much for supporting us and for the team as a whole. It's been great working with you all. You all are very good at what you do, and your own writing style has made this very nice. And I'm glad to have worked with all of you.
Parents, we haven't heard from some yet. So I was referring also to any closing comments from parents.
Absolutely. I think this was this is a great project and a very interesting one. Research obviously is done for something that is not known, or but this opportunity that has been given to the kids has opened up the eyes and the avenues, the way they are looking at and understanding the world. And like when Jyot was looking at medicine, she was only focusing at medicine, nothing beyond that, right? Whereas we are living in a world where computers and the computers and technology is influencing every realm, and it is helping us and all the future careers will have interaction of computers, and this is a good start for the kids to have in high school. Good job done, and thanks Bob Singh ji for your guidance and ideations.
Certainly, Ji. So guys, good work, all three of you. You learned research skills, collaboration, project management. You came in with 3 different lenses. You did a deep dive in your own respective ways and then came together. This is unlike any other school project where you weren't really, there weren't any rules or boundaries. And you created your own rules and boundaries, and through your own experience with the merely 10 to 15 hours a week ballpark for 8 weeks, you delivered what you did. And I don't think these 30 minutes have captured everything that you have learned. There's probably a lot more. Going forward, high schoolers have to become multidisciplinarians because you can't just know one thing. So, Jayant, we're asked a lot of questions around the potential future from your own realm, and you were suggesting other disciplines. So, like a degree in neuroscience, degree in biomedical engineering. Those are key for creating the bridge along with physicians. So it's eminent while school systems are so, I mean, the only multidisciplinary degrees exist are liberal studies. Schools are slowly going to change in the near future where you will need to cross-train. But until then, if you pursue a degree in computer science, don't hesitate taking a course in neuroscience or biomedical engineering. Or if you're pursuing political science for law, don't be afraid to jump into a little bit of Python and AI and maybe an intro to neuroscience course. So all of those aspects are helpful. And speaking to the future of this project, it affects about 14 different areas. And I'll enumerate those as a consideration for future research. We have neuroscience, biomedical engineering, of course, computer science and AI, which is kind of implicit. There's electrical and computer engineering along with robotics, the work that Tesla is doing, and that discovery is available in Tesla space. We need impressions of math and stats that need to come together. Human psychology. Cognitive science is very important, which is a branch of psychology, but at the same time, studied independently can produce really, really cool stuff. Areas we haven't talked much about yet is robotics or material science. Pravan spoke of responsible AI. Rehabbing with medicine. So one thing, Igjot, you may consider is, say, somebody with a neurological condition like neuropathy. When the sensations are not, like the myelin sheath dies, and it enables or disables the transmission of signals to parts of the body, making those numb, especially for diabetics, which is a high percentage of our population. There is a deeper consideration of what medicine integrated with artificial intelligence can implement. And I think if you consider, that's a personal passion project of mine and that I will put out. And if you consider that in the future, I think is going to be really cool in the integration of this with medicine. And then there's, of course, linguistics, how education will change. You guys spoke a lot to that. And I'm hoping classrooms don't exist after 2035. Cybersecurity, regulatory science, with laws, etc. So this was our first version of the project that we did based on this HBI. And if you guys want to partake in future research areas, definitely stay in touch. Let's do more. And we'll get more folks involved in our Discord interface or in our Discord channel and create a community around this, guys. All right. Thank you very much.
Thank you so
Have
much.
a wonderful rest of the day, everybody.
Thank you.
too.
Thank you. You too. Bye-bye.
Bye, everybody.